Right. Hello, everyone. This is Abdullah Bogari from SPS Scientific Business Solution. To start, I would like to thank the organizers for arranging this platform to exchange knowledge and network. The presentation is going to be about sustainable construction thinking toward more sustainable future. Just before we start, a little bit brief about Scientific Business Solution. It's a consultancy firm that has several offices around the globe in different disciplines. And so we have sustainability and environment solution consultancy for the business, waste management solution for alternative fuel and alternative raw material, calibrations for laboratory equipment, training and certifications, environmental monitoring equipment, quality management system. And we are focusing more in the region of MENA, Middle East and North Africa, but there is several offices around the globe. Right. So to start with, we'll talk about an overview about the CO2 emission in the building sector. It's being clear that the world leaders are focusing more and more about CO2 emissions, putting solid and concrete framework to reduce that emission. But why is that? Why all the focus on these CO2 emissions? We understand that the global warming is one aspect. Let's have some focus also about where is the CO2 emissions coming from. The building sector account for 38% of all energy-related CO2 emission, and that's when adding the building construction industry emission to it. Also, the construction material, or the ready mix in particular, is the second highest consumed material globally after water. And this is one of the reasons why there is a lot of tension about reducing CO2 from the construction sector. Another fact is that if the cement industry was a country, it would be the third largest emitter in the world, and that's behind China and US. Now, process of cement. Talking briefly about the process of cement manufacturing. For a single normal home, it would be required to have 15 tons of cement, and to produce 1 ton of cement, we must have, or that must burn around 110 kilogram of fuel and spend 110 kilowatt on electrical energy, dig around 1 meter cube of stone in the quarry, exchange 6,500 kilogram of air in the process of producing cement, and also evaporate 170 kilogram of water in the cooling process, also in producing the cement. All these aspects are consumed and used in a process of just 36 seconds. Now, what can we do about it? How we can optimize the building sector? We cannot stop developing, but we can do something else. We can focus more and more on the carbon circular economy, moving from the linear economy, which is take, make, use, dispose, affecting the environment and causing pollutions, toward more alternative economy that focus on reuse, recovery, recycling of the material. Now, there are several methods to reduce the carbon footprint in the cement industry, but I will focus on four main elements that can help in reduction of the emission in the cement. The first one is carbon capture and storage, where the emission from the cement kiln or the cement stack can be captured, stored, and reused for different process or industry. Another method is to work on alternative novel cements. We will come to an example on that later as well. Also, clinker substitutions. Clinker is the main raw material for cement, and it accounts for the most of the CO2 emission in the process. So having a substitutions for the clinker would help a lot in reducing the carbon footprint. And the fourth element is to reduce the use of the cement in the building or in the environment itself. So digging a little bit deep in the carbon capture and storage pillar, we can see that in the diagram an example where a carbon can be captured from the cement and then reused as enhanced oil recovery. Basically, oil giants company can use the carbon to enhance the flow of the oil from the ground. And by doing that, we have also an advantage of storing the CO2 under the ground. So it is two in one, enhancing the recovery of the oil and storing the CO2 under the ground. Moving on, alternative cement. A lot of or some of the technology R&D institutions working on introducing cement or growing cement using bacteria, and this also can sequesters carbon. So that is an example. A lot of effort yet need to be taken to develop such technology and commercialize it on a higher scale. Clinker substitution. So to explain more about clinker substitutions or cement to clinker ratio, basically the clinker is the main component to produce cement. We can say that 90% of the emissions coming from the cement is from clinker production. And that's why by reducing the clinker in the cement, there's going to be a huge environmental benefit. Here is one example of 1 ton of clinker produced. There is around 0.87 ton of CO2 emitted. And the second point is, for every 1 ton of OPC or ordinary Portland cement, which is the common cement used globally, there is around 0.8 ton of CO2 emitted. Now, there are several types of other cements that can be used in building material, like pozzolana or pozzolanic cement, masonry cements, blended cement, and by introducing natural material to the cement and reducing the clinker factor, we can reduce the CO2 or carbon footprint within the clinker. An example is for the pozzolanic Portland cement. We can see here that the PPC, 1 ton of PPC produced will be equivalent to 0.68 of CO2 emission. So that's give us a result of 15% CO2 saving compared to the OPC, just by introducing natural material pozzolana instead of higher volume or ratio of clinker within the mix. Another material is, or another example is the masonry or finishing cement, where that cement is used in tile flooring, in the finishing, where you don't need a very high strength of cement. And an example of masonry cement produced can save around 23 to 25% of CO2. Moving on to the fourth element that can reducing the cement within the cycle of building, and an example of that is using the 3D printing technology, where we can save the waste of cement and the waste material in the process itself to around 30%. Now, moving on to the waste management part, here is a comparison between the incinerations, landfilling, and the co-processing technique in the waste management. The waste management hierarchy on the right shows that, of course, the best way to manage waste is to avoid producing waste, and then to minimize it, then recover the material like recyclable and reuse material. After that is the co-processing. What is co-processing? Co-processing is the recovery of the energy and material within a certain process, like the cement, where we introduce alternative waste as alternative energy and alternative raw material. And there are several advantages for that. We will also cover it in the next slide. And then after that comes the incinerations. And after that, of course, you can see that the physical pre-treatment, chemical and physical pre-treatment, and then landfilling. Moving on, so what we can do here is we can provide waste management solution within the industrial sector, focusing more on cement plants, where it can play a major role as a heart of many industrial ecology synergies. Cement plant can accept different type of waste from municipal sectors, power plants, construction sector, demolitions, chemical, petrochemical, all that industry, or all these industry provide waste, and these type of waste can be reused, recycled as a source of alternative energy or alternative fuel and alternative raw material within the cement industry. Moving on, okay, so moving on, what are the common types of waste that can be used in the cement plant? These are examples where tire-dried fuel can be used as waste. It can be used as a whole tire or shredded tires. Municipal waste or RDF, refuse derived fuel, can also be used. Carbon, excuse me. Carbon fly ash or soot coming from the utility sector also can be used in co-processing process. Of course, petroleum waste like oil sludge and bottom tank oil, and dry sewage sludge coming from the sewage treatment plant. Here is an example. I would like to share a video. So this is a video about a landfill in Jeddah, Saudi Arabia, where it has more than 12 million tires dumped, and we provided a solution to recycle these tires using the cement plant. These are Google images for the landfill 2 years ago. So on the left side, you can see that the landfill was full of tires, where there was around 1,200 million dumped tires in the landfill in July 2019. 2 years later, you can see the difference. There is a lot of empty spaces where these already been recycled and reused as an energy source in the cement plant. The consumed tires within this period was around 4 million tires. Okay, moving on. Carbon ash recycling. Just to give an overview about carbon ash. Carbon ash is a hazardous material with heavy metal content, and it's produced by the utility sector, power and water plants. For the past 20 years, these material being landfilled in the western region or in some regions. And the cost annually to landfill such a material was around 18 million USD. Working closely with cement plants in the region, we managed to build and provide solutions where this material can be recycled and reused as a source of energy. Today there are 14 different utility plants sending their carbon ash to cement plant to be recycled as a waste to energy. The total carbon ash recycled since 2017 is around 144,000 tons, which is equivalent to 24,000 bulker. And the cost saved by the waste producer by recycling this material compared to the landfilling is around 80 million USD since 2017 till today. So how can you help us, or what can we do to help the environment? Individual change of behavior towards sustainable thinking is a very important aspect. Engaging with NGOs, governmental policymakers on supporting sustainability also is crucial for individuals, governmental entity, private entity, public figures, and policymakers. Also, to educate ourselves and encourage others about advancing technology and recycling waste, especially in developing countries. Also to engage with businesses and industries for collaboration on sustainability solutions. Thank you very much. These are some examples of our clients that we are working with them on sustainability and environmental solutions. Thank you.